What is up, folks? We are back live with Big Time Math Test 2 review. Today we're talking about the domain and range and transformation. So if you can do those things on test number 2, folks, you are going to rock it like no other and be awesome. So let's see what you can do. And we're going to go ahead and start with questions number 1 and 2. All right. So it says the domain is the set of all what values. Automatically, folks, you know what I'm writing when I see domain and range? I don't care where it is on my paper. I'm going straight to the Dr. XY. If I write Dr. XY, that automatically tells me the domain goes with the BAM! X values, yo. So if domain is X values, that automatically tells me that my range is my Y values. All right, so domain is always your X and range is always your Y. If you can remember that, this is going to be pretty simple. So let's check this out. It says which inequality best describes the domain. So automatically, I'm writing domain goes with the X's. So since it goes with the X's, you know what I'm going to do? I'm going to come look at my answer choices. And automatically, 2 answer choices cancel right out. Since it's domain, check. X's, check. I come over here. I've got X, X, Y, Y. So automatically, you know what I can do? Peace out. These answer choices automatically go away because I'm only looking at the X values. Now, this says find the domain. So I know domain is also left to right. Beyonce said to the left, to the left. So I'm going to go look at my X axis and go as far left as possible. So here's the origin right here. So go left, 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 bam, stop right here. So I know I have to have that number. And I'm going to go ahead and go to the right until I can't go to the right anymore. And it looks like it stops right here at this number. Remember, when I'm looking at domain, I should only be looking at values on the x-axis. You shouldn't be jumping around and looking up and down when it says domain. So I know I have to have a -3 and I have to have a 1. So automatically that cancels out an answer. But before we get too much further, remember, if it has 2 stopping points, it stops here and it stops here, then my answer will have 2 inequalities. So I'm going to go ahead and put X, automatic, 2 stopping points, 2 inequalities. 2 stopping points, 2 inequalities automatically. All right, and so my left number was -3, my right number was a +1, and if I notice, at -3 I go up, it's an open circle. Open circle, remember, is not included, so I'm not going to put it equal to. But if I go over to the right, 1, and I go all the way down, BAM! That's a solid circle. So solid circle gives me a solid line, which is an equal to. Therefore, this is my domain. And just because I know the 2 answers, this has a 2 in it, wah, wah. Peace out. Your answer should have been A. Left to right, 1 is included, 1 is not. Remember, 2 stopping points, 2 inequalities. Domain, folks, is left to right. Don't forget that. Next question. Now, this is a word problem. It says Melissa was driving in her neighborhood, okay, and approached a stop sign. When she applied the brakes, it took 6 seconds to come to a complete stop, and from a speed of 30 miles per hour. If Melissa creates a graph of her speed versus time as she applies her brakes, which of the following would describe the range? Now, I see the keyword range, so range, I always write Dr. XY. And so range automatically tells me that I'm looking at the Y values. The Y values, okay? So just because I know that, I come to my answer choices. This has an X value. It's gone. Y value, check. X value, gone. Y value, check. So one of those answers is going to be correct. So let's just kind of draw our graph. Now, she's starting at 30 miles per hour, right? And then so up here, I like to say starting point is 30, okay? And it said it took her 6 seconds to come to a complete stop. So here's my 6. This is really helpful because if 6 is seconds, which is time, which is X, which is independent, then I know that my range, which is the Y, is dealing with 30 miles per hour, is my y-axis. So already right there, that should tell you your answer. But let's just go ahead and make sure we're on the right track. if she's coming to a complete stop and it takes 6 seconds, she's at 30 seconds here, she's starting to slow down, and then at 6 seconds, she gets to 0 miles per hour. So, I can see that range, if you talk to Drake, range is always bottom to top. Remember that, BT, bottom to top. The bottom range value, the bottom of the graph right here is 0. The top of the graph is 30. So I know that my range is from 0 to 30. Plus, it has 2 stopping points. It stops here and it stops here. Therefore, I have 2 inequalities. It does, BAM! Touch at 0, so that's included. It does, BAM! Touch at 30, that's included. So my range is between 0 and 30. Therefore, my answer must be B. If you chose D, you were looking at the domain, but remember, domain is 0 to 6, but that's the X values. This says Y values, so it doesn't really match up. You must remember, folks, range goes with the Y. Domain goes with the X. That right there is going to help cancel out half of your multiple choice answers. It's pretty sweet. So, what this is saying is she's going from 0, or her speed, which is Y, can be anywhere between 0 and 30 miles per hour. All right, pretty simple problem there. We're going to go ahead and move on for time purposes. Next, we got here 6A. We're looking at domain and range of quadratic. So the graph shows the height of a ball versus one bounce. Find the domain and range of the quadratic function. So the bounce height, we bounce that mug, BAM! It starts at 0, and then it goes all the way to a certain height, and then it comes down to the ground, all right, or somebody caught it, something like that. So domain, automatic, Dr. XY. That way I know domain is X's, range is Y's. Now, I'm looking for stopping points. Since domain is left to right, range is bottom to top, I've got to follow the directions, yo. So, domain, left to right. Here's a stopping point. Here's a stopping point. Oh, wow, I have 2 stopping points. So, oh, wow, I have 2 inequalities. What's the furthest number to the left? 0. What's the furthest to the right? What is that, a 2? So, my time is between 0 and 2 seconds. Now, does it have an open circle? No. Closed circle. Closed circle. So that means I can include it. So my domain is definitely between 0 and 2. 0 and 2. Now remember, domain is X values, so I like to put a big X right there at the end, and I'm only looking at this axis for domain, 0 to 2. My graph is between 0 and 2. But if we're going to look at the range, like Drake said, started from the bottom, now we're here. We're starting at the bottom and we're going to the top. So now I'm only looking at the Y values. I go down, BAM, stops here. Then I go up all the way and it stops right about here. So the bottom range value, I'm only looking at the Y values. It has 2 stopping points. Oh my gosh, that means 2 inequalities. That's your hint. 2 stopping points, 2 inequalities. It stops at 0. And it goes all the way up to 16. So, it stops right at 0, BAM! Inequality, and 16. If I go across, that's a solid line. It's part of the graph, so it does include that point. So it's included right there. So my range is all the numbers between 0 and 16. My domain is all the numbers between 0 and 2. As long as you know that D domain goes with X and R range goes with Y's, these are going to be fairly easy. Now just remember, let's talk about some attributes right here. These 2 points here are known as your zeros, x-intercepts, and solutions. All right. This point right here, does anybody remember? Just quick review. That's your vertex. It's right in the middle. Max or min? It's a max. Don't forget that. And then if I did my axis of symmetry, which cuts it right in half, it looks like x equals 1. And if we're going to be big baller shot callers, that vertex is 1/16. And remember, your axis of symmetry and your vertex share the x. Just a little quick review there. Vertex is the highest or lowest point. Axis of symmetry cuts that mug right in half. All right, going down to the next problem. Does it say the graph of the quadratic function f of x equals negative x squared minus 4 is shown? What's the domain and range of this function? Guys, I'm teaching this and I still write Dr. XY every single time. Okay, so domain is x, range is y, and I come over and I check out how many inequalities am I going to have? Well, domain is always left to right, so I'm going to the left. Here's 0. How far left can I go? Whoa, that has an arrow, and that arrow's never going to stop. It looks like it's going down, but it's also going to the left. So it's going on forever, forever, ever? That's weird. So I go to the right. Remember, it's left to right. It's going down to the right, but it's going on forever, forever, ever, forever, ever. So if it's going all the way to the left, all the way to the right, notice how I'm saying the word all. Guess what? That means my domain is all real numbers, okay? Domain is all real numbers, or all x values, however you want to say that. But all the numbers to the left, all the numbers to the right, means all real numbers. There is no stopping point with your domains. If there is no stopping point, guess what? Then it's all real numbers, because it goes on forever, forever, ever. Now let's look at the range, which is your y. Remember, started from the bottom, now we're here. Now in this case, the bottom, the arrow, goes on forever, forever, ever. So we know the bottom goes on forever, but the top has a stopping point. So this is forever, this stops. Therefore, one stopping point means one inequality. And where does it stop? 1, 2, 3, 4. It stops right at -4. So watch how I do this. If you notice up here, it stopped here and stopped here, so it's 2 inequalities. But right here, it only stops once because the arrow on the bottom goes on forever. Therefore, I have 1 inequality. But we got to figure out what inequality that is. If this is -4, yo, is it all the numbers above it or below it? And if I'm looking at it, I'm thinking it's going down, so it's below. So it's all the numbers less than -4. And since it's touching right at -4, there's no open circle. It's included. So there's my range. All the numbers less than -4. So -5, bam! -6, bam! -7, bam! No matter what number I go less than -4, it's always going to hit that graph. So, 1 stopping point, 1 inequality, 2 stopping points, 2 inequalities, and guess what? If there is no stopping points, it's all real numbers. Rewind that and check that mug out, you know what I'm saying? All right, A9A, talking about domain and range of exponential functions. Same deal up in here. So let's see, given this exponential function, find the domain and range. Well, automatically, I always write x and y, always write dot. If you wanted to left to right, bottom to top, whatever you need to write down to help you remember that, write it down. So let's talk about domain. Domain is left to right. Now, since this is an exponential, and it does tell you that's like exponential, I'm going to assume that they have arrows going on forever. So, domain is left to right because I wrote that down. The furthest left is an arrow, so it's going to go all the way to the negatives. The right is an arrow, so it's going to go all the way to the positives. So it's all the negatives, all the positives. Therefore, guess what? All real numbers. Don't mess that up. You can do that, yo. All the x values, every single one of them. But this is where it gets a little bit tricky for the y's, because y is bottom to top. So where is the bottom of the graph? And it looks like it's right here. But remember, with exponentials, we talked about this crazy word called asymptote. So I'm going to just draw my dotted line right here and keeps going. So it looks like it's trying to touch that dotted line. But with asymptotes, remember, it's approaching the asymptote. It's never going to touch that mug. So, started from the bottom. This what I would consider a stopping point. Eventually, it's going to try to stop at this. So we call this a stopping point. And then up top, we have an arrow. So there is no stopping point. So, when there's no stopping points, it's all real numbers. When there's one stopping point, it's one inequality. So Where did it stop? Or eventually stops at the number 1. And just like we did in the last problem, in this one, is it all the numbers above 1 or below? And you just go with the arrow. It says, hey, yo, we're going to all the numbers that are above. So if it's all the numbers above 1, that means they're greater than 1. Now here's the trick part. Since it's an asymptote, it's never going to touch it. So we do not put an inequality in this case. We just say it's every single number greater than 1. Let's check it out. Would 2 work? Yes. Would 3? Yes. Would 4? Yes. 5, and so forth. Every single number greater than 1 is going to work. Therefore, that is my inequality. Remember, no stopping points, all real numbers. 1 stopping point, 1 inequality. If it's greater than, it's above. If it's less than, it's below. Moving on, here we go. Kicking butt. Talking about transformations now. We're going to label each part of the equation indicating the changes that occur. Remember we talked about x's lie. If it's inside, it's changing the x value. So this is talking about the factors. You know, if you got 1/5 and 4, and we'll talk about that here in just a bit. And this is left to right. And remember, if it's talking about your x's, it's that horizontal shift, okay? So we got a horizontal shift of some sort. And if it's on the outside, we said it tells the truth. You do exactly what it says. So this is going to be some type of vertical stretch or compression. All right, we'll just go ahead and write that down. Stretch or compression. And if it's out here, it's a vertical shift. All right, a vertical shift. But you just do it exactly. If it's plus, you go up. And if it's negative, you go down. The most tricky part is right here with the C's, because you always do the opposite of what it shows. If it's plus, you actually go to the left. And if it's minus, you go to the right. So let's check this out. Let's see what you do on these problems. Here we go. All right, it's a matching game. We're going to match the following transformations to the corresponding equations. All right, so let's check this one out. This one says right here, g of x equals 4x plus 4. Since it's inside, I do the opposite. And it's dealing with the x. Now, x is left to right, but we're doing the opposite. So plus, I would think I'd go to the right, but I'm actually going to the left. And how far am I going? 4. And that's the only change I see. So if I have the origin or the parent function, I start at 0 and I go to the left 4. Let's look at this one. Nope, that's going down. This one is going to the left, but it's also going down. This has nothing to do with going down. This one, whoa, the whole graph is going down. We don't want that one. This one's going to the right and up, not that one. Uh-oh, check this out. To the left 4. 1, 2, 3, bam! There it is. That graph is the only one that went to the left 4. Therefore, E is that matching graph. Next one. We have 2 transformations here. This negative out front tells me it's going to flip. We automatically know that. Now this minus is on the inside dealing with the x's. So he's saying, hey, you think I'm going to go -2, but I'm actually going to the right 2. The right 2. So we need something that flips and goes to the right 2. Well, if I'm looking at this, the only one that does flip is A. But let's check it. It flips, now it's going down negative, and it went to the right 1, bam, 2. So it's got the negative because it's going down, and it's got the right 2. Therefore, A is my answer here. Again, if you're watching this video and you want to change or pause or do any of that, definitely take your time to pause and rewind to see what the explanation is. All right, this next one says g of x equals f of x squared minus 5. But the minus is on the outside. When it's on the outside, we're going up or down. It's a vertical change. And we do exactly what it says. Outside is cool. So he says minus 5. I'm automatically thinking that's down 5. Okay? Because it only affects the y values. So let's look at this. Which one's going down 5? Here, oh, this one went down and moved over. We didn't say move over. We just said go down. C goes down 1, 2, 3, 4. Bam! There it is. That's the graph that moved exactly down 5. We're just going to check D. That's not down 5. So the only one that went down 5 is C. All right. You are doing great so far, folks. Great job. Next one. Uh-oh, it has 2 changes here. We already know this affects the x's, but it's doing the opposite. So on the x's, I'm going left or right. I would think right, but since it's plus, I'm actually going left. Left 3. And then this one outside means down 5. All right, that's pretty cool. So we got a left 3 and down 5, and we only got 2 more choices left. So this one didn't go to the left, so that can't be it. This one's, let's check it out. It said left 3, 1, 2, 3, and then down 5. 1, 2, 3, 4, bam! There it is. So B is my answer. Left 3, down 5. We have one more answer choice, and it should match up, but let's just go ahead and talk about this one. Minus in the inside, we do the opposite, so we're going to go to the right, 1, and then plus 1 on the outside says, hey, you do exactly what you see, up 1. So let's check out the answer D. Right 1, up 1. Bam! There it is. So there's my answer, D. Again, if you want to watch any of this and go backwards, you can. Just remember, inside the parentheses, you do the opposite. Outside, you do exactly what it tells you. Okay, the function below is a transformation of the parent function, y equals x. Draw the parent function first. So let's go ahead and draw the parent function. If we remember, parent function always starts at the origin, and for y equals x, always has a slope of 1. So I'm going to go up 1 over 1, up 1 over 1, up 1. You can go down 1, back 1, down 1, back 1, and so forth. And so if you connect your dots, you have your parent function. But it says identify the function that represents the equation for the transformation. If P is your original parent function, the question is, what is the other graph going to be? So this bad boy, I'm going to draw it in orange, okay? So what transformation happened? Now I have 2 choices here. Since it's linear, it either moved up 1 or it moved to the left 1. Now, both of those transformations happened, but let's go ahead and look at the answer choices down here. A says that it has a negative slope. Well, negative slope means it's going down, but this graph, the orange, is definitely not going down, so it can't be A. B has a negative slope again, which means it's going down, so it can't be B. So we know it can't be B. Now this answer C, I've already marked it out because this has a -1, which means it's going down 1. But there's nothing there when I went down 1, so it can't be C. So the only other answer choice here could be D. This says +1, and it's on the outside of parentheses, and there are no parentheses here, so it only affects the Y, which means it goes up 1. And if I'm at the parent function, up 1, bam! It is D. All right. Now, if this was an answer choice, X +1, the +1 means actually do the opposite and go back 1, then I could have had that answer choice. Both of these answers are actually correct when it comes to linear. So be careful when you're checking your answer choices. What I would do is I would go through and make sure that all of the wrong answers cancel out before I choose one. Next type of problem. How would you graph y equals 4x plus 3 when you change the y-intercept to negative, or change it to -2? So let's just follow the directions. It says first off we need to draw y equals 4x plus 3 and label the y-intercept. Well, 4x plus 3, so I'm going to go up to 3, starting point. Now I can't go up 4 and over 1, so I'm going to go down 4 and back 1, down 4 and back 1. Let me just show you why that works. Because now if I go up 1, 2, 3, 4 over 1, bam, 1, 2, 3, 4 over 1, bam, 1, 2, 3, 4 over 1, bam. Okay, so I'm just going to connect my dots, and it looks something like that. All right, so we have the original function. It says, what is my slope? Well, my slope is always the number in front of x. So in this case, it's 4. My y-intercept is 3. It did say label the y-intercept, so we're just going to go right here. That is my y-intercept. Okay, so my y-intercept is right there. You know what I'm saying? Now it says draw and label a new y-intercept at -2 and determine which transformation below happened. So let's do purple. So my new y-intercept is -2, but it didn't say my slope change. So I'm going to go up 1, 2, 3, 4. Wait, 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1, and so forth. So I connect the dots. And since my slope didn't change, you should have a parallel line. So let's see what happens to our graph. A says, did we move it 5 units down? Well, here's my y-intercept, 1, 2, 3, 4, 5. Bam! We actually did. But I want to check the other answers. Did we move the original graph up 5? No, because that'd be off the graph, so that's wrong. The slope of the line would increase. Did we say anything about changing slope? No, it said only y-intercept, so that's wrong, and it wouldn't decrease. So just by checking our answers, we know for sure our answer is correct, A. All right, and then, so that's good. And if you're a really big baller shot caller, you could say, well, the slope didn't change, but the y-intercept did. And so you could see from +3 to -2, it went down 5. Finding slope and rate of change. How do you find the slope and rate of change of a graph? Well, we just did it. We did rise over run. You find 2 points and you count. And how do you find the rate of change or slope from a table of 2 points? Use the formula. Remember, y2 minus y1 over x2 minus x1. Whoa, x1 right here. And you always just change of y over change of x. Change of y over change of x if you're using the formula. All right, folks, we have one of our last questions here. It says a tank holds a certain amount of gallons. A pump is draining the full tank at a rate of 35 gallons per hour. Identify the following, what they represent or mean, by reading the answer choices below. All right, first question says, what is the x-intercept? Well, x-intercept means I need a x value, so I need the number, then a 0. So you need an x value. And in this case, let's go look at our graph. Well, x-intercept, I go to the x-axis, I find my point, bam! That number happens to be 20, 0. So I'm going to write that down, 20, 0. Now, it says circle the one it represents, A, B, or C. So we're looking down here at this box. 20, 0, is that the rate? Automatically, I can stop. Rate means slope, so that's not it. Is it the number of hours it took for the water to drain from the tank? Well, let's see. X-axis, 20, and hours. They all go together. So I'm going to put a check right there just in case. And let's check C, the amount of gallons a tank started off. Does 20 have anything to do with gallons? Because no. If right up here, oh, there's gallons, and that happens to be with the Y. So we know the answer is B. Now the y-intercept, it says, is a form of a number and 0 or 0 and a number. Well, it's always 0 and a number because y-intercept, you need a y value. So if I come over here to the graph, I'm looking for the y-axis. Here it is. And bam! Looking at the y value right there. Okay? Now it looks like to me that number is 700. So I can go 0, 700. My x value is 0. My y value is 700. All right. Now, circle the one it represents. Does that y-intercept represent the rate? Nope, because that's slope. Does it represent the gallons it started off with before it started draining? You notice how the word starting, started, and gallons? Well, here's gallons, and this is where we started. The y-intercept is usually your starting point. So in this case, it is C, your starting value. Now it says, what's the slope of the graph? Now you got to be careful here because the graph, automatically I see the graph is going down. And you're reading it left to right. Okay, you're draining, so you're running out of water. So I better know my slope is negative. And since the problem already told us, we don't have to calculate that it's at a rate of 35 gallons per hour. So I'm going to put 35 over 1. Okay? And the rate means slope at which the water is draining from the tank. So we know this case is A. All right. Now, if we want to figure this out really quickly, you could personally just use your 2 points here and here. Let's go ahead and calculate that out. So I'm going to call this x1, y1, whoop, and call this x2, y2 just for fun. And let's put it in the formula. If you want to do y2 minus y1 over x2 minus x1, let's just keep it going. My y2 in this case is 0. minus y1, which is 700, over x2, which is 20, minus x1, which is 0. I'm just plugging in the numbers. 0 minus 700 is negative 700. And then 20 minus 0 is 20. And you just reduce that down to 35 over 1, which happens to be your rate of change or your slope. All right. So you can find slope by hand, or you can take the clues from the problem and find your slope. Remember, slope is always rate of change. And if you're looking for your x and y intercepts, always match it to the word or words that are on that axis. Next type of problem here is we're looking for true and false questions. The graph below represents a golf ball hit from the side of a hill. So true or false? The golf ball hit the ground at 15 seconds. So did it hit it at 15 seconds? Well, we know this is height, this is seconds. I'm going to write this a little bit bigger for you. And we're going to go over, bam! What number is that? It looks to me like it's a 15, 0. Did it hit the ground? If this is height here, and this is time, did it hit the ground at 15 seconds? Well, looks to me like that's definitely true. Hit the ground right at 15 seconds. So we don't need to write a correct statement there. Now it says right here, the time in seconds of the maximum height is 80 seconds. Well, I'm looking at the problem. I see, well, this happens to be the maximum height, and it says that's 80 seconds. Well, if I come down here, whoa. That number's 5. And how could it be 80 seconds if the most seconds is 15? That's totally weird. So we definitely know that the answer isn't 80 seconds. So that's going to be false. But could we say that the time of the maximum height is, what's this number? 5 seconds. So we could say the time of max height is 5 seconds. All right. So the time of the max height is actually at the 5-second mark. So that's good there. Now it says here the maximum height of the golf ball reached is 60 meters. So was the maximum height 60 meters? Well, here's 60. Was that the highest the ball was at? No. So we know that's false. So what was the maximum height? Here's 60, 65, 70, 75, 80. So this number here is 80, and that's the highest it got, right? So the highest that this graph is, we can say the max height is what? Or max height reached, let's just say that's where you get 80 meters, all right? So we know that max height is 80. And when did it do that? At 5 seconds. Just using our graph to give us some answers there. Now that next part says the initial height was 60 meters. Hopefully you know that initial, and if you want to write this down, that means where did it start? Well, it's got a point right at 60. So to me, you know what? That looks like a true statement. It started right at 60. So the initial point, or the initial height, is 60 meters. So if you got T, F, F, T, you are awesome and you did it correctly. If you didn't, that's perfectly fine, because remember, this is just a review, folks. You're just using it for your test. All right. We got an exponential graph right here. We're almost done. The exponential graph shows the change in the value of a car over several years. The first question is this a growth or decay? Well, the graph, if you read it like you read a book, left to right, it sure looks like it's getting smaller. If it's getting smaller, we're going to call that a decay. So the graph is definitely a decay. What's the initial value? The problem just before we did this, initial means where does it start? So to me, I'm going to say a good point is 12. Now, this is where you got to be careful, because it's 12, but it's in thousands of dollars. So it actually starts at $12,000. Everybody see how that works out? Okay. This is also known, well, initial value, starting point, and it's on the y-axis. So what can we call that? You're right, the y-intercept. That's the starting point. Now, what is the y-intercept? Well, that's pretty simple, because we already got our value here. And a y-intercept, we automatically know The x is always 0. We just need a y value, and we already found it, so it's 0, 12,000. Now, what's the equation of the asymptote? Now, the asymptote is the line that the graph is approaching. So I see that it's right here, so I'm just going to go dot, 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 go straight across, and then bam! There's my number. So check this out. It's the number 3. It's on the y-axis, so therefore my asymptote is y equals 3. You just do your dotted line straight across. It looks like it's trying to get to that number, and your dotted line is your asymptote. Remember, your dotted line is your asymptote, so y equals 3. Now, does this graph have a constant rate of change? So, is it changing the same all the way throughout the graph? And I would say definitely no. It's steeper right here, and then it starts getting less steep, less steep, less steep until where it's almost flat. So there is no constant rate of change. That's going to help you on the next part, so let's check it out. Based on the information from the graph above, label the following true or false. So let's see. The car lost about 1/2 of its value every 3 years. Every means constant. We already said this isn't a constant, so it did not lose 1/2 of its value every 3 years. So that's definitely false. And if you want to check it out, okay, the first 6 years, or first 3 years, it was at 12. Now it's at 6. So let's just write that down. It lost 6,000. And then from 3 to 6, it's right here at 4. But in here, it only lost 2,000. So did it lose half? 2,000 is not half of 6,000, so that's definitely why it's false. The car lost about 1/4 of its value every year. Every, again, stands for constant. Does it have the constant change every year? No, so that's false. Now, the next part, so check it out, says the car lost more of its value between years 9 and 10 than it did between years 1 and 2. Let's see, from 9 to 10, I'm going right here to right here. It lost, I want to say maybe $200 from right there. It only lost $200 value. Okay, it's close because this is 3,000 and this is 4,000, and that's way between there. So it lost between 9 and 10, $200. But between years 1 and 2, here's 1 and 2, let's see how much it lost. I'm going to go right about here to here. Well, between that number, if this is 7,000, that's 8,500, it looks like it lost $1,500 worth of value. So between 1 and 2, it lost 1,500. Between 9 and 10, it lost 200. So the question said, it lost more between 9 and 10. 205. No, it didn't lose more. That's definitely false. It lost more between 1 and 2. So let's look right here. It lost less between 9 and 10 and then more than 1 and 2. That's definitely true. This is less than this, so this is my true statement. Got that? All right, folks, that, I believe, is your review. I wish you the best. Good luck. Remember, you can watch this video at any time. Study that review, and you're going to rock it on test number 2, all right? Peace out for now. This is Big Time Math in the Algebra Accelerated Academy. Peace out.